Awesome. Okay, so hi everyone. I hope you're all doing well. My name is Daniel Locomotion, and I'm a third-year student at the University of Cape Town in South Africa. Funny enough, I actually just finished my third-year exams 2 days ago, so I'm quite tired, and I can't say I've had much sleep recently, but I'm doing okay overall. Anyway, in this presentation, I'll be giving an overview of the research paper I did with my professor, where we explored natural walking in impossible spaces as a locomotion technique in VR. Now, before we dive in, it's important to understand what a locomotion technique actually is. Put simply, it's the means by which users traverse a virtual environment. How do we get from point A to point B? For those of you familiar with VR, the first locomotion technique that may come to mind are teleportation and touchpad or joystick. But there are many more, including arm swinging and, on the more expensive end, omnidirectional treadmills. This ability to traverse a virtual environment is considered an integral and indispensable part of user interaction, but it's also one of the reasons why VR today isn't as immersive as what it could be. Artificially replication locomotion it's just that. It's faking it. So why not just walk around? Unfortunately, the physical confinements of our real-world surroundings restrict us from being able to physically move around in the virtual world. And so this has led to developers opting for these artificial techniques that I've mentioned above. There are, however, a few consequences of using these techniques. Firstly, it damages immersion and the sense of a presence, since users are forced to move around unnaturally. Next, it introduces a potential learning barrier, since non-gamers may find it difficult to get used to the many different buttons and controls. Finally, it can even cause feelings of simulator sickness, which occurs when conflicting signals from users' eyes, ears, or skin are sent to their brain regarding self-movement in the virtual environment. So we therefore need to come up with a different strategy, one that still makes use of natural walking, but prevents us from hurling into our living room furniture. In our paper, we explored a relatively under-researched locomotion technique that uses impossible spaces to allow for an infinite amount of virtual space to be traversed within a finite amount of physical space. Now, it's a bit challenging to visualize this, so let me talk through a demonstration. At first glance, everything may appear normal. The player is seemingly walking around a procedural maze and exploring new environments. But as you can see in the bottom right-hand corner, he's actually just walking around in circles. So what's going on? How can he be walking into new virtual spaces while walking around the same physical space? This is where the concept of impossible spaces comes into play. Here, an impossible space is essentially just an illusion, much like the Penrose staircase, which appears to climb upwards indefinitely. These are spaces that are impossible in Euclidean geometry, but through clever manipulation of the environment, can become a reality. The game that we saw previously used portals to achieve this effect, by seamlessly teleporting players to a new environment in order to redirect them around their play area. There are other methods to achieve a similar effect, but such as using opaque doors to swap between rooms, but they're much less convincing. For our research, we decided to go with portals, but it ended up being a bit more challenging to implement than I would have hoped. I won't be going into the nitty-gritty of that in this presentation, though, since we've covered it in detail in our research paper. So why haven't you heard of this technique before? The clip of the game I showed a few slides ago was actually from one of the few VR games I could find using this as their predominant means of traversal. Perhaps this is just a novelty and shouldn't be taken too seriously. Well, that was the aim of this research, to conduct a formal investigation on the viability of this as a locomotion technique by comparing it both objectively and subjectively to three conventional techniques, namely teleportation, arm swinging, and touchpad or joystick. We chose these techniques due to their prevalence in VR games today, and also because, along with natural walking, they cover the 4 distinct types of locomotion in VR. For subjective assessment, we used questionnaires, including the Simulator Sickness Questionnaire, Game Experience Questionnaire, and System Usability Scale. These were chosen to address the consequences of the artificial locomotion techniques that I mentioned before. To objectively assess these techniques, the time taken for users to complete a set of tasks while using a locomotion technique was recorded. Now, before we can dive into those results from these assessments, we first need to take a step back and discuss the tasks that candidates were required to complete for the experiment. Firstly, an important point to mention here is that because of the COVID-19 pandemic, we had to design the experiment in such a way that meant candidates overseas could participate without the need for constant guidance and supervision. Usually, we would have a dedicated room in a lab on campus where participants would perform the experiment under the same conditions, but that unfortunately wasn't possible since we were all at home. This also meant that we couldn't recruit university students, and so we had a significant lack of potential participants. Fortunately, I was able to recruit quite a few people online with a $10 incentive, of course, and also drove out a few hours to family and set up my VR rig for them to participate. In the end, we had a reasonable sample size of 25, considering the current sanitary conditions. To ensure fair treatment, in-person candidates then performed the experiment as if they were by themselves. So what did participants actually have to do in the experiment? The main goal was to get them to move around the virtual environment in order for them to be able to assess the locomotion techniques. To achieve this, we spread out several tasks around 4 different houses, one for each locomotion technique. We had to create 4 different environments because the impossible house needed to be designed specifically with portals in mind, as you can see those black doorways in the bottom right-hand corner. If we use the same house for the other 3 techniques, it would have introduced a potential learning bias. On that note, the order of locomotion techniques presented were randomized to mitigate the effect of learning bias. So before participants began completing tasks around the house, they were introduced to the locomotion technique using a tutorial. They were then tested to check their understanding on how to move around. Once they had completed the tutorial, they were then presented with a clipboard with a list of 3 tasks they needed to complete around the house. While tasks differed for the sake of variety, the amount of work required to complete all tasks for a given house was designed to be the same. The first task, as you can see at the top there in the clipboard, comprised multiple actions that were dispersed to ensure users moved around the entire house. So the empty bins was scattered around the entire house, and they had to move around the entire house to learn the environment. The second was positioned at a single location. So wash dishes was just at one location. And finally, the third was, in all cases, to return to the starting position and set the alarm, which was symbolic of leaving the house. Now, the different tasks for each technique were as follows. For teleportation, they first had to turn on all the lights, then boil the kettle, and finally set the alarm. As you can see, turning on lights got them to move all around the house, and boil the kettle, bottom left-hand corner, was to navigate to a single location in the virtual environment. And then finally, setting the alarm was at the beginning where they started. Right, so for touchpad or joystick, they first had to empty all the rubbish bins, then wash the dishes, and finally set the alarm. For arm swinging, they first had to fix all the wall plugs, then watch TV, and finally set the alarm. And lastly, for natural walking, they first had to collect all the towels, then light the fireplace, and for the last time, set the alarm. After completing a set of tasks for a given house, they were then asked to fill out the Simulator Sickness Questionnaire, Game Experience Questionnaire, and System Usability Scale in that order. At the very end of the experiment, they were then presented with their times and were asked to fill out the Google form. All right, so now we can discuss the results. In total, 300 questionnaires and 96 timings were considered in the study. One user's times had to be excluded, however, as they had to arrange furniture while performing the experiment. With regards to the demographics of participants, we had a reasonable number of both experienced and inexperienced players, and a range of different aged players. We also had roughly the same number of tethered and untethered candidates. In analyzing our continuous measures, so game experience, simulator sickness, system usability, and task performance, we applied the Shapiro-Wilks test of normality on the residuals. In cases where we found with statistical significance that residuals followed a normal distribution, a repeated measures ANOVA was performed to determine whether a significant difference between techniques occurred. Otherwise, normality wasn't assumed and the Friedman test was applied. In cases where a significant difference was found, we followed up with a post hoc Tukey's HSD test for normal data, or a Wilcoxon matched paired sign ranked sum test for non-parametric data to determine which particular treatments differed. So now for the actual questionnaires. For the SSQ, no significant differences were observed that included natural walking. However, as you can see at the bottom, we did observe significant differences between teleportation and touchpad and joystick and arm swing. Interesting to note that this was observed in previous papers that we had read. Okay, for the game experience questionnaires, we noted that participants felt significantly more immersed when using natural walking over all the other techniques. They also felt significantly more positive about natural walking over touchpad or joystick, and significantly less negative about natural walking over arm swinging. On the other hand, users found natural walking significantly more challenging than teleportation and touchpad or joystick. After further investigation, we found this to be mostly a positive result, as participants mentioned they enjoyed the challenge. In other papers, it has also been found that if utilized correctly, some level of challenge is actually known to be a large factor in remedying boredom. For the system usability scale, we noted that participants felt significantly more, that participants found natural walking to be significantly more usable than both touchpad or joystick and arm swinging. Finally, for the times, no significant differences were observed that included natural walking. It was hypothesized that task completion time may have increased due to users with lower levels of spatial awareness becoming disoriented. However, referring back to the SSQ, no significant differences were obtained with regard to natural walking and disorientation, so we could rule that out. While these scores may bode well for natural walking, there are certain downsides to this technique that we need to discuss. Firstly, the minimum play area requirement was 2.5 by 2.5 meters. While we automatically resized the house to accommodate for players with different play area sizes, we had to impose this restriction as the house became too small to navigate past this point. This could have been prevented, however, had we been able to perform the tests in person. We also noted that impossible spaces are quite tricky to design and aren't suitable to some types of games. In conclusion, natural walking in impossible spaces shows promise because it strikes a balance between immersion, usability, and relatively low levels of simulator sickness. One major caveat, however, is the difficulty of constructing these environments. Overall, though, I'm more than confident that this could become a fantastic solution to creating more immersive VR games, and I look forward to seeing it being used more in future projects.